Well, we're here to see how we can work better together. Within Server project, we have several sub-projects. One very active one is OAI, Open Accelerator Infrastructure. Another one that has formed since last year and is very active and actually produced a specification just recently is the Data Center Ready Modular Hardware System, DC-MHS. With the spirit of working better together, it seems that a modular hardware system and a modular OAI should be able to help each other. So that's basically here we are today to have that conversation.
Oh, I have this turn on. Hello, I'm Song. I'm with Meta. I'm the co-lead for the OAI sub-project.
And I am Ahmed Abou-Alfotouh from AMD and also another co-lead for OAI sub-project.
Right, and OAI sub-project is a sub-project under Server project. John Stewie and Mark Shaw are the co-leads of the Server project. And I am the rep to, Server rep to the incubation committee. It's great to be here.
Technical.
Wait.
Yeah, it's glitching.
Let me see.
Yeah, it's flickering back there on the screen back there. I just took you off the screen because it was flickering. And
It happened to us yesterday also.
As we are waiting for the slides to come back alive, you can recall, I'm sure you recall that OAI was formed as a sub-project in 2019 around an Open Accelerator Module, OAM. Immediately after contributing OAM, it was very clear that we needed to have a system around it. A lot of companies got together and created a concept called OAI, Open Accelerator Infrastructure. Within that, we had several chapters, UBB, Universal Building Block, Host Interface Board, Power Distribution Board, concepts for extending the reach outside of the chassis using the accelerator links, for example. So that was a modular hardware system together. It was formed before, for example, DC-SCM as another modular element was conceived. And then before DC-MHS as a system around DC-SCM is being worked through. But they do have a lot of commonality, so much that OAI team about a year ago realized that, yeah, they could use perhaps the modular hardware, modular DC-SCM, the Data Center Ready Modular Secure Controller, and include it within the OAI. They worked hard enough, and they eventually did that. Several companies, 3 companies, built systems around it in the form of a reference design, so much that in certain areas, as a tray element, for example, they were interoperable. That was a great modular hardware system at the time around accelerators. But now we have a formal subgroup, or it's close to be a subgroup, it's a work stream, that's called Modular Hardware System. So far, the focus has been around single socket and dual socket servers, but in the architecture, they share a lot of commonalities. So it does make sense for us to get together, bring the 2 subgroups together, and look at each other's work and collaborate and moving the concept farther.
Good.
Doesn't work.
Working.
We still have difficulty displaying the slide deck, but I think we can just walk through
I think we can just walk through, yeah.
Mm-hmm. Yeah, let's just
So,
through.
you want to do some intro on OAI?
I think Siamak already did.
Already did. Okay, good.
Again, continuation to what Siamak was saying, that the contribution from OAI started in 2018, officially March 2019, starting with OM, as Siamak said, and now today we have 7 contributions from not only OM, not only UBP, it's 7 cards that we're trying to come with a spec with. But early this year, released the 1.5 spec for the OM and UBB. By the end of this year, for the all work streams, are trying to release the 2.0 for the UBB. And now, how the connection will be to others, that I think that's what we're going to discuss today. And probably we can talk more about the UBB until the slides are up.
Yeah, let me just provide some
additional
content, right? What we have done, what are the workstream members that we have, and we talked about it yesterday, but I would like to talk about it. We have like around 28 members right now in the workstream, contributing on the high-speed system, cooling, power, and OEM too. So it's great to see that all the companies come and join and contribute into the spec. Yeah. And like what Ahmed mentioned before, that we are not only working on the single platform. What we are trying to do is that to come up with the more like an infrastructure system solution for the AI HPC application, that including the GPU module, or what we call OEM module, and base for the interconnect topology that the solution supplier provided, right? And on top of that, like this year, we are working on what we call the expansion module. What the expansion module can be done is that you can use that as a scale up with the retimer, or you can have a different topology. You can, and at the same time that the expansion module, you can turn it into a remote memory, NIC interface, etc. Right? So what the whole the scope of the project is that we want to create a flexibility in terms of the architecture that is not only tied with certain technology, right? You can plug and play, and with the different technology, because the work that we have done is on the platform. It's going to be protocol agnostic. You can have a CXL, or you can have a PCIe, or some other interface as well. Yeah. And one major thing that we want to talk about today is the how can we work together with DC-MHS, right? If you look at the OS system, it is like a standalone system, and it also needs to connect to the compute node, right? Now we talk about how are we going to connect to the compute node. There are different ways that we can do that, right? One of the things is that is the whole architecture. Is that going to be a PCI switch topology? Is that going to be a direct connection? So those are the work that we are going to work closely with DC-MHS, like how to define the interface between the OAI system to the DC-MHS. Yeah.
Right. One of the concepts early on was OAI defined a structure around the accelerator compute elements, UBB, although it is a universal building block. In other words, it defines the input and output to that block. Within that block, people can do whatever they wanted to do. But most of the people have done accelerators and GPUs. Having a accelerator GPU tray, then people normally connect it to a head node. A head node normally is a dual socket server, sometimes even a 4-socket server. So in some incantation of that, there has been a retimer and PCIe cable between the two. That's a possibility. People have done that. Another variation of that, Grand Teton, just new contribution by Meta, introduced these modules all within a chassis. So the cable interconnect is inside the chassis. So it reduces some of the complexities that might be present when you have different chassis. It creates different challenges, but challenges are for smart people to resolve. So all in all, when we're thinking about solutions in a modular way, other people can come take advantage of a component of it in a different model. For example, within the DC-MHS, there is a good definition of a host processor and memory module, HPM, that could be a head node. Now, such a head node from a DC-MHS team can couple to an expansion chassis or expansion module, such as UBB, and do something good, right?
Yes, yes. Yeah, definitely. I think that is another thing that we are going to work closely with the DC-MHS is that in terms of the AI architecture, right, and how can we best fit, like what Siamak mentioned about disaggregated system or versus an aggregated system, right? What we try to look into that some sort of solution that we can apply to both of the architecture. And still, because DC-MHS, they're focusing on the modular motherboard, right? And then we still have a lot of pieces that need to also involve as well, like OAI, HIB, which is the platform that we can have a PCI switch for the topology that we want to have for AI application. Yeah.
Is Alan Cantel in the crowd? He leads another subgroup within server project called HPC. HPC guys, by their name, are very much interested in compute elements that are power capable. They have seen UBB as an interesting building block for their work as well. They have innovated around OAM. They have innovated around UBB itself. They have thought about UBB not being just a PCB, it is cable connected as well. So they have seen these building blocks as useful, and they're building around that as well. This particular picture is showing 8 OAMs. These are OCP Accelerator modules, but UBB defines flexible topology. The concept that we used at the beginning was wires are wires. So the topology, a number of topologies have been defined. People can do different topologies if they wanted to at the UBB level, but at the OAM itself, it supports several fixed topologies. Now, what goes on an OAM mezzanine connector could be whatever you like. It could be a processor, it could be a networking device, could be even a storage device. And that's what HPC guys have taken advantage of. They have built modules that are a combination of memory and compute elements in that mezzanine slot. And this diagram is showing that, yep, you have compute, but compute needs to talk to outside world. And to the right of the diagram, there are some interfaces that might be proprietary interfaces or might be standard interfaces such as PCIe or CXL. At the time that we conceived this, people thought that it could be OpenCAPI. 2 years ago, when that was a very valid choice. C6, OpenCAPI, Gen Z, any of those would have been valid choices. On the other side, you see that to scale out, modules like this would like to be connected through some networking element. And for networking element, we have yet another module. That module is a NIC. And that NIC could be proprietary NIC for proprietary backend network. It could be a public network, could be Ethernet, RoCE V2, or RDMA based on InfiniBand, for example. All of those are possibilities.
Yeah, I think I want to emphasize that what Siamak mentioned about for the scale out, right? That's what we call the expansion module. Yeah, it can be a NIC, it can be a smart NIC, it can be a remote memory, it can be a scale up, direct scale up from the OAM, or it can be a crossbar switch, right? So the way that we define on the baseboard is that how to interconnect or the OAM to the expansion module through the UBB with a certain topology that we provide. It's a reference topology. And then the work stream that is going to study based on the speed rate requirement right now for the UBB 2.0 expansion 1.0, we're going to target for 112 gig. And then we're going to look into all the SI and power aspect, making sure that the design is robust. So if anyone wants to deploy the solution, that will be best for them. Mm-hmm.
So having the hardware done is just a good portion of the story. It is not complete. When these products want to find their ways into data centers, either enterprise data centers, hyperscale data centers, or edge data centers, they need to be housed in chassis and eventually want to run software on them. An infrastructure software that maintains security, management, performance, telemetry, test and validation is necessary to make hardware work well. So that's another aspect of the work that we can do together, not just the hardware piece, but work on software elements for standardizing on those elements as well. So that's another overlap perhaps that we could expect as we work together on DC-MHS and OAI to consider that we eventually would like these hardware elements to interface to software. And from software point of view, if they can view the hardware as standard, they're happy. If the management are using around Redfish, DMDF, PLDM for security or such, if there are standard elements that we can take advantage, we should, so that the work that software guys do transfer from one system environment, DC-MHS for example, to modular GPU or accelerator infrastructure. A concept that Andres offered a couple of days ago as part of Future Technology Symposium was this multi-brain concept, Tintinfish, as he called it. So if we can work together, define modules or arenas, as he called them, and each one manage itself to some degree, but they all work under a central element, those could work well. This concept that I just talked about could work with DC-MHS as well when we start with an HPM and we have add-in boards that are smart add-in boards, or expansion chassis that are smart expansion chassis plug into HPM I/O slots. A UBB, for example, can be such expansion chassis having its own management controller, but being under control of the head node or the DCSCM that is part of the head node. So all of these things can work together well as long as we architect it together, as long as we know where we want to go and we walk through this meandering together. Actually, Andres is there, right? No, I don't see him. It's too much light. So what are your plans for OAI?
OAI, they still have a lot of work, like what I showed you. We have like 7 projects going on. Right now we are focusing on the 3, which is the top priority right now. Once we get done with that, we're going to work on the HIB PDM, and also the UBB tray, right? And also the SCM that Siamak mentioned about. So those are the things that is going to be continue driving in the work stream. Yeah, and then it's going to be very interesting to see that how the interface, the HIB board, right, interface to the DC-MHS, how can we come up with a solution that fit for the good for the industry. Yeah.
And of course, pushing the power. At 1.0, it was up to 700 watt only per OM, and now we are pushing the power per OM to 1 kilowatt and adding the expansion. Expansion depends on the topology. Is it retimer or switch? It can be 200 watt or 400 watt per expansion module, and now we're adding 8 of them, 8 modules. So 8 kilowatt for the OM and another 400 watt per modules. So that you are talking about 10 kilowatt baseboard. That's huge push for the baseboard power from the starting point when we started this project. So a lot of exciting happening for the OI and UBB and OM. A lot of challenges. It's at all levels. It's the high speed, the power, thermal, mechanical. A work stream working all together to put all of this together. And as Siamak mentioned, that we need to work with other work streams, how now to interact and connect everything together.
We have about 2 minutes. Perhaps maybe we should open for some questions.
Yep.
With UBB 2.0, do you see it as being stable for a long period of time, or do you think that you already have ideas for moving onward to UBB 3.0? Just kind of looking for that long-term prediction. Thank you.
Yeah, I think we have been talk about that. Like Ahmed and I talk about the UBB 3.0. We have some folks asking for that, and I think with the working right now, because we know what is because there is a lot of work to be done on the 2.0, and then we are still focusing on the 2.0. But for the 3.0, because of if you look at the new AI solution, right? Like there's a lot of new technology. This is something that we are still watching and see if we can still move forward with the 2.0 to be compatible, or we need to come up with a new architecture that to fit with the new technology. So this is something that we're also looking into, right? Like for instance, you talk about like a lot of the service routing right now is based on electrical, right? But people are talking about the optical photonic and also the co-packaging, CPU, GPU co-packaging stuff, right? So this is something that we are watching. But because the whole industry is not ready for that yet. So one that's ready, then we are going to look into the solution for that probably will be on the OAI 3.0.
And I would like to say that also we need feedback from the community about, okay, what are the challenges that you are facing today? What are you looking for the OAI to solve? What do you see how the future is going? We have ideas and we have communication, but we need more active contributors. We need more active members to contribute also to this project. There are a lot of ideas. Which one will meet your requirement? Which one will be more effective than the others? Okay.
Great. Thank you very much.
Right, thank you.
All right, thank you guys.
Thank you. Thank you, Simon.